write and simplify expressions from real-world problems. Now, this is a really important day for us today, and I think part of the reason why I say that is because I feel like on our Unit 1 test, one of the places we struggled the most was when we had word problems or real-world problems that we were trying to deal with and figuring out what we should be doing in terms of operations with those real-world problems. So today is going to be kind of another opportunity to pick up some of those things that maybe we missed during Unit 1, but also to focus on some of the new things that we might see here in Unit 2 and how those play out in real-world problems. So I want you to be super focused today. I did change your seats, and remember, part of the reason I changed your seats was so I thought you had great partners. So if you see your partner opening his book while I'm talking, you should probably give them a nudge and say, hey, I'm your partner and I'm looking out for you. I want you to do your best. Please put your book away. Or if you see maybe your partner is doodling while he should be taking notes, perhaps you might want to nudge them and say, hey, I want you to do your best. Please go ahead and take your notes. If you see your partner staring off into space and doing absolutely nothing while they should be taking notes, you might want to nudge them as a gentle reminder like, hey, I want you to do your best. Please start taking your notes and paying attention. Okay? So, please make sure that throughout an entire period, and that's part of the reason why we have the seating changes that we have, is so that I put you in great partnerships where I think everybody has a partner that not only can help them be successful in terms of learning the material, but also in terms of meeting the expectations of the classroom. Okay? All right, so this first one says, Tim has a basket of 12 apples and is picking apples at a rate of 45 apples per hour. Nicole has 20 apples and is selling them at a rate of 10 apples per hour. Elsewhere, Andrea has 80 apples and is selling them at a rate of 35 apples per hour. Write an expression to represent the total number of apples they have after H hours. So we're looking for the total number of apples that these three people have, which means on a very basic level, I know that I need to add up however many apples that each of these people have. So I'm going to start with what I call kind of a pseudo-math equation, which means that I'm just going to represent this as immediately, I need to know Tim, how many apples he has, plus Nicole, how many apples she has, plus Andrea, how many apples she has. So this is just kind of, I call this pseudo-math because it's kind of math. It's got math symbols in it, but it isn't necessarily using the numbers and variables of the problem. So I want to start with Tim, and I want to start with how many apples he already has, because that's going to be my starting point. How many apples does Tim already have? Jacob? 12 apples. And it says he's picking apples at a rate of 45 apples per hour. So is he adding to the number of apples that the group has, or is he taking away from the number of apples that the group has? Give me a kip yes if he's adding, and a kip no if he's taking away. Good, so we're going to say that he's adding. Now, he's adding 45 apples, but over time, he's going to add more than 45 apples. He's adding 45 apples per hour. So how can I figure out how many apples he picks based on the number of hours? What am I going to have to do here? What part of this expression is going to tell me how to figure out how many apples he's picked after H hours? How can I figure that out? How can I figure out how many apples he's picked after H hours? Ayla, what do you think? Yeah, 45 times H. Thinking about it in terms of if I was just plugging some numbers in, 45 after 1 hour, he'd have 45. After 2 hours, he'd have 90, because 45 times 2 would give me 90. All right, so that's everything for Tim. Now I'm going to move on to Nicole. Nicole has some apples already that she can add to the group. How many apples does she already have? 20. And it says that she is selling apples at a rate of $10 per hour. So give me a kip yes if she's adding to the amount. Give me a kip no if she's taking away from the amount of apples that the group has. Give me a kip yes if she's adding to the amount that they have or if she's taking away from the amount they have. Right, so if you're selling things, you're giving those apples away. Obviously, you're getting money in return, so you're not really giving them away. But it says that she's selling them at 10 apples per hour. So what do I want to do? How do I want to put that into our expression? Sammy? So he's saying plus a negative 10h. We also could think about it as a subtraction. It doesn't really matter. But if we think about it, we can think about that as she is taking away. So that's why we're definitely having either that addition of a negative or that subtraction. They're both the same thing. We know that. All right? That's all we know about Nicole. So now we're going to move on to Andrea. And Andrea already has some apples she can contribute to the group. Luis, how many apples does she already have to contribute to the group? 80. And then it says that she is selling them at a rate of 35 apples per hour. How am I going to put that into the expression to show that she is selling 35 apples per hour? Kelsey? Yep, we could write it as plus negative 35h, or we could write it as a subtraction. It doesn't really matter. That change switch can happen either way. I like how we, though, decided to do it all as addition. The reason I think that's really nice is because that means we can immediately do what? Crescent. Yeah, we can immediately commute. We don't have to leave change switch first. All right? So now we want to simplify this expression. Remember, part of the reason why we would want to simplify this expression is if I wanted to figure out what was happening at different hours, I would have to plug in h 3 times, multiply 3 times, and then add 5 times, the way this is currently set up. But if we can simplify it, if I want to plug in a bunch of different numbers, we may be able to get something that's easier to work with, has less operations to do. All right, so the first thing that I'm going to do is I'm going to go ahead and commute, as Crescent suggested. I'm going to put all of my h terms together. These are my like terms. Then I'm going to put all of my constants together. Remember, those constants are terms that do not have variables. So here I'm going to go ahead and use my associative property. So I can go ahead and combine my like terms. I have 45 plus negative 10h, and I'm just going to do this 2 at a time because sometimes I make mistakes. So this is going to give me 35h plus negative 35h plus, and after I combine these two, that's going to give me 32 plus 80. Sorry about my sloppiness over here. That should have been a 35h. And here's something really interesting is going to happen. I have 35h plus negative 35h. What does that equal? 35h plus negative 35h. Ivana? 0. Because 0 times h would be 0. It doesn't matter what h is. So we end up with 0. Oops. End up with 0 plus 112. So what's really interesting about this is that this simplifies to just a single number. Well, let's think about this really quickly and think about what this really means in terms of the real world. It says 0h. What does that mean in terms of the real world? Aaliyah? No, take a shot at it. What do you think that means in terms of the real world? Something's happening every hour, and it does have to do with 0, absolutely. Jaquan?
It's not a full hour.
It's not a full hour? No, I mean, whatever we put in to H is whatever it's going to be. So we don't really know what that is. We can put in half hours or full hours. What do we think it means, 0H?
They're not selling more than what they are getting.
Yeah, they're selling exactly as much as they're getting. They're not changing the number of apples that they have by hour. There's no change per hour. They're always going to have 112 apples because they are selling exactly as much as they are picking. So it's almost like they're picking it off the apple tree and tossing it out to the person they're selling it to. Okay? So think about that in terms of real world. This also means that when we break it down to just this 112, that no matter how many hours go by, that they will have 112 apples at the end of that hour. All right, next one. Ms. Crosby is working to pay off the loan on her car. She earns X dollars per hour at one job with a $200 bonus at the end of the week, and Y dollars per hour at another job with a $250 bonus at the end of the week. She works 25 hours for the first job and 23 hours for the second job. Write the expression to represent the amount of money. Okay, so we want to write the expression represents the amount of money she earns in each week. When we read back through this problem, we see that she's earning money from 2 places. She's earning money from job 1 plus the money she earns from job 2. So again, we kind of see that pseudo-math equation, that kind of math equation that kind of helps me set up and think through how the rest of this expression is going to get. So looking at job 1, how much money does she earn from job 1? How can I represent that? Callie. X times H. So you're thinking, tell me what that X times H means to you.
Dollars. She earns $6 every hour.
Yeah, so you're multiplying X times the number of hours she works. Well, if we look through this problem, we actually know how many hours she works at that first job. So let's read back through.
25H plus 200.
25, what's the variable? X for the dollars per hour. So one thing that I think a lot of us need to catch on to is when we see rates like this, dollars per hour, if we want to find out how many dollars, we can multiply whatever the per is. So in this particular case, we're looking for X dollars per hour. If we want to find out how many dollars, we can multiply by hours, which they tell us in this case is 25. So 25 times X. Does she earn any other money at job 1? Kip yes or Kip no. Does she earn any more money at job 1? Katarine, what else does she earn from job 1?
20.
How much? How much? How much money? Read back through the problem. Everybody read back through the problem one more time. Figure out if there's any more money that she earns from job 1. 200. Where does that come from? Bonus. All right, so she earns a $200 bonus. Let's move on to job 2. Job 2 tells us she earns Y dollars per hour. How am I going to represent how much money she earns in her hourly wages? How am I going to represent how much she earns in just her hourly portion? So again, we see that kind of that rate here, that dollars per hour. Which means if I want to find out how many dollars, I can multiply it by number of hours. So how am I going to represent How am I going to represent how much money she earns in her hourly wages at her second job? Monica. 23x. Now it says for her second job, it's Y dollars per hour, so it's a little bit different. So we're going to make it 23y, and that's one of those small details that we have to pay careful attention to. One of the reasons why that's so important is because does that make it a like term or an unlike term for 25x? Everybody, unlike or like? Unlike or like? Unlike, yeah, it's different. So that means that we're not going to be able to combine them. So that's really important that we catch that. Now, does she make any other money at job 1? Or job 2, excuse me? Jacob, what else does she earn at job 2?
She earns a bonus of $250.
Bonus of $250. Now, if we want to simplify this expression, we want to go ahead and do our commuting. I usually put all of my variable terms at the front, and then I put my constant terms at the back. So even though I can't combine the 25x and the 23y, I'm putting them next to each other so my constants will be together at the end. Now I can use the associative property and I can combine like terms. Just for make sure that we are crystal clear, Kip yes or Kip no, can I combine 25x and 23y? No, because they are unlike terms. All right. 25x plus 23y plus 450. Got it. All right. On to the next one. All right, you go to the store to buy a shirt and a new pair of jeans. The jeans cost J dollars normally, but are on sale for 40% off. The shirt costs $20. The total price can be represented by the expression below. Actually, we're going to write the expression below because it tells us to write the expression. So we want to find out our total price. The total price, part of it is going to come from the cost of the shirt plus the cost of the jeans. The shirt's the easy part. How much does the shirt cost? How much does the shirt adding to our total price? Dahlia, $20. The jeans gets a little bit trickier. The jeans should add how much to our total price normally? How much would the jeans normally add to our total price? Read through the problem. The jeans add J dollars to our price normally. However, there is an amount taken off of that price. And what's taken off of that price is 40% of the value of the jeans. How do I find 40% of the value of the jeans? How do I find 40% of the value of the jeans? This is one of the places where I feel like we need to go way back in a time machine to our 6th grade class and remember, hey, how do I find 40% of some number? Giselle. 0.4. That's it? That would suggest to me that I'm going to subtract 40 cents from the jeans. Yeah, times the J. Because remember that what we learned in 6th grade was that if we took a part, or a fraction, or a percent, and we multiplied that by a whole, that gave us the part. So the part that we're trying to figure out is, we're trying to figure out what 40% is. So part of that whole is 0.4 times J. 40% of the jeans would be 0.4 times J. And we're taking that off of our price. Now we want to go ahead and combine like terms because we're already associated. Now, I see that when I combine like terms, I usually add the coefficients or subtract the coefficients. But Right now, J doesn't have a coefficient. It doesn't have a number out in front. Jasmine, what number should be out in front of that J if I want to use its coefficient? Yeah, a 1. So now I know I should be adding 1 and negative 0.4, which means realistically, should I be like signs add or different signs subtract? Subtract. So I'm subtracting 1 and 0.4. So should that look like this, 1 minus 0.4? Kip, yes or Kip, no. Should my subtraction line up like this? This is where you have to track the board and answer. Should my subtraction look like this? No, what's wrong with this? Adrian? Yeah, the place values aren't aligned. I really like the way she said that. All right, so our place values aren't aligned. So we need to change that. So it looks like this, and we get 0.6. So 20 plus 0.6. Is that right? Everything's done? 20 plus 0.6? No, what's missing, Giselle? So I borrowed, yeah. So I'm looking over here at my expression. What's wrong with this expression? What's missing here? Aaliyah, what's missing here?
A negative?
No, we did take the sign of the larger number. The larger number was the 1. What's missing, though? This would suggest that I am taking 60 cents from 20, or I'm adding 60 cents. The jeans only cost 60 cents. I'm pretty sure you do know, because I'm pretty sure I heard you say it. So when we combine like terms, do the variables just disappear? No. So what am I missing? The J. And there's our simplified expression. All right, and the last one. It says Brandon can paint 1/3 of a house per hour, and Melissa can paint 2/5 of a house per hour. If Brandon has already painted 1/6 of a house, and Melissa has painted 3/5 of a house, write the expression below that represents how many houses they will paint in H hours. So we're thinking about this. We know that in H hours, Brandon will be able to paint some houses, and Melissa will be able to paint some houses. So we're going to be adding the amount that they paint together. So we're going to start with Brandon. Brandon has already painted some amount of houses. What is he already painted? What can we already add to their total of houses painted? John, what can we already add to the total of their houses painted?
1/3. Yeah, 1/3 of the house is painted.
That's not what it says. It says that he can paint 1/3 of a house per hour. So I want to know how much he's already painted. How much can we already add to their total right now? Brandon, since this problem's about you, I think you can help him out. Yeah, so he's already got 1/6 of a house. Now, we want to talk about what he's going to be able to paint in the next H hours. So again, we see that house per hour thing. So if I want to find out how many houses, I need to multiply 1/3 by what? Adrian? H, his number of hours. So in H hours, he'll be able to paint 1/3 times H. So again, we can think about that in terms of multiplication. In 1 hour, it's 1/3. 2 hours, it's 2/3. 3/3, 4/3, and so on. Now we need to talk about Melissa. Melissa has already painted some amount of houses. She's already added some amount of houses to their total. Edgar, how much has Melissa already added to the total? 3/5. That's what she's already added. And she's going to continue to add to that total over the next few hours. At what rate? Kelsey. Yeah, 2/5 houses per hour, which means 2/5 times h would tell us how many houses she paints in h hours. Now all we need to do is we need to commute. So we can simplify this expression. 1/3 h plus 2/5 h plus 1/6 plus 3/5. Want to go ahead and associate my like terms. And this is going to get a little bit more complicated because it's going to be harder to add 1/3 plus 2/5, but it's not like that's tough fractions for you to add. You guys can do that. So we'll go ahead and just do that work off to the side. 1/3 plus 2/5. I'm going to need to get common denominators. And I can see that I'm going to get 11/15. And when I add my fractions over here, (1/6) plus 3/5. Again, I'm going to need to get common denominators. Oops, 6/6. And I'm going to get 5/30 plus 18/30. And I'm going to get 23/30. Everything I have written on the board is okay, correct? I'm ready to move to the next step. Brandon, I couldn't tell. Was that a kip yes or a kip no? Brandon, why not? What's wrong? Yeah, I forgot my h. Can't combine like terms and then lose your variables. Because now we notice, hey, this is as far as we can go because I can't combine my h term with my constant. Questions about that?